To begin the preparation of the copper standards for titration, add 10 milliliters of dilute nitric acid to the copper sample, cover the flask with a watch glass, and heat on medium heat till completely dissolved. While the samples are heating with the nitric acid, red-brown gas may dissipate. This is normal. When the sample is completely dissolved, make sure that all traces of copper wire are completely in solution, and the red-brown gas will begin to dissipate. While waiting for the samples to dissolve, it's okay to periodically mix the solutions in the flask. Notice that as the copper dissolves, the solution takes on more of a pale blue color, and the red-brown nitrogen oxide gas intensifies. When the sample is completely dissolved, there will be no traces of copper wire present in solution. At this point, remove each sample from the heat. Allow each sample to slightly cool, and then rinse the underside of the watch glass back into your flask. At this point, you're going to dilute the sample with about 25 milliliters of deionized water. And then to remove nitrogen oxides, you're going to add 10 milliliters of a 5% urea solution, and then boil each sample for 2 to 3 minutes to eliminate those nitrogen oxides. The heat may be increased slightly at this step to allow the samples to reach a boiling point, and don't forget to have the watch glasses removed so that the nitrogen oxides will be able to escape. Time the 2 to 3 minutes of boiling time once the samples have reached a boiling state. Notice the samples boiling at this stage. This will continue for 2 to 3 minutes. After the boiling step, remove each sample from the heat and allow it to slightly cool. The next phase in the preparation of the copper samples is to pH adjust. This requires the use of the following reagents: concentrated ammonia, 3 molar sulfuric acid, and 85% phosphoric acid. Begin the pH adjustment phase by adding concentrated ammonia to the slightly cooled samples, swirling after each addition until the appearance of an intense blue copper ammonium complex forms. Smoking is normal here, and squirting the ammonia down the sidewalls of the flask is helpful. Okay, notice the appearance of the deep purple blue complex as a result of adding the ammonia. To the deep blue complex solution, the next reagent to use is 3 molar sulfuric acid, and you're going to very slowly add this dropwise, swirling after each addition until the color of that deep blue complex just disappears. But you're not going to add so much that you go all the way back to that original pale blue state. You're going to be somewhere in between the pale blue that you started with and the deep purple blue. If you add too much sulfuric acid to the point that the solution becomes too light, you can make it deep purple blue again with the ammonia. This flash shows the point at which the deep blue colored complex has just disappeared with the addition of the 3 molar sulfuric, and you'll notice that it's a shade somewhere between the pale blue that you started with and the deep purple blue when adding excess ammonia. The final reagent to add in the preparation phase is the 85% phosphoric acid solution. You're to add 2 milliliters of the solution to the sample. Phosphoric acid's very viscous, so it may be better to remove the 2 milliliters via a pasture pipette. And you'll notice upon adding the phosphoric acid, the solution turns a pale blue color. At this point, you could parafilm these until ready for titration. At this point, all 4 standards are chemically prepared and ready for the point of titration.